Question 4 is coming from connected particles. The pulleys, two particles A and B have masses 0.3 kilograms and 0.1 kilograms respectively. The particles are attached to the ends of a light inextensible string. The string passes over a smooth fixed pulley and the particles hang vertically below the pulley. Both particles are initially at a height of x meters above the horizontal ground. The system is released from rest, but find the tension in the string and the acceleration of the particles. Now we need to put the forces that are acting on these particles here. When we go to B here, there is weight which is acting downwards. That one is going to be 0.1 then times G, because weight is mg. Okay, weight is mg. And then there is tension which is generated in this string. Is the same tension here because the same string here is passing over this pulley. Then also A here has gotten its weight, which is 0.3 G. When you look at these two, A is heavier than B. So meaning when the system is released from rest, A will go down and then B will go up. It's the same system, so the same acceleration. Now we look at the forces which are acting on these particles. Okay, we look at them individually. Remember, we are going to use F is equal to ma. So when you look at the forces which are acting on A, the weight here is bigger than the tension. That's why it can move down here. So we shall have 0.3 G, then minus the tension, then is equal to the mass of A is 0.3, then times A. And then when we go to B, the forces which are acting here, the net force, this one means the net force. So that is the tension is bigger than this one. That is why B is moving up. So we shall have the tension, then minus the 0.1 G, then is equal to 0.1 A. Now I can add these two equations to eliminate the tension. Why? Because this one is a minus and this one is a plus. Now 0.3 minus 0.1, that one will give us 0.2 G, which is equivalent to, when you add this one, you will get 0.4 of A. So that means acceleration here is going to be equal to 0.2 times acceleration due to gravity is 10 over 0.4. Of course, this one is going to be a half. Okay, then a half of 10 gives us a 5. So acceleration is equal to 5 meters per second squared. Then we substitute in any of these two equations to find the tension. So I'll use the second one. Tension is going to be equal to 0.1 of A, then plus 0.1 of G. It's a plus because this one goes this side and it changes the sign. So here we have 0.1. It is even common. Then the acceleration here is 5, then plus G, which is 10. So meaning we are having 0.1 times 15. And that one gives us 1.5. So meaning the tension in that string is 1.5 newtons. That is that. During the subsequent motion, B does not reach the pulley. When A reaches the ground, it comes to rest. Part B, given that the greatest height of B above the ground is 1.2 meters, find the value of X. Now, in our sketch, we are having this one as the pulley. Okay, then A, let's say, reached the ground here and the string becomes slack. Okay, the string is slack there. Now there are three positions here. Probably B is here. Okay, but at first B moved a distance here. Then there is also this distance here. Okay, so B moved up. It was initially here, so even A let's say A was here, and then moved this distance down, which is x. Okay. Then B also was here. This is the final position for A. It moved up. As this one was moving down, B was moving up. Okay. So this one moved this distance x, even B moved that distance x. Okay. It came to that one there. Then there is a further distance B moves. Okay. There is a further distance B moves when this one reaches the ground, and then it doesn't move. So there is that free fall. I can say free fall or free movement under gravity. So there is another distance moved here, which we need to find. Okay. Now, when A reaches the ground, we need to find the distance, the speed with which it hits the ground. It will be the same speed with which B comes to this position here. So I can see B here and then also here. Now, first, we are going to find the speed with which B, A, hits the ground. So using the equations of motion, so V squared is equal to U squared plus 2AS, we can have our V here, which is equivalent to the square root of this. The system was released from rest, so we have 0 squared then plus 2 times the acceleration. We have gotten it as 5, and then the distance traveled is this x here. So that is x, meaning our V here is going to be equivalent to the square root of 10x. Okay, then after that, this is the same speed as B here. Okay, so same speed for B. I can say here same for B. Okay, then next, when A reaches the ground, the string becomes slack. Okay, therefore the tension in that string is equal to 0. Okay, so if the tension is equal to 0, then we need to find the acceleration of the movement here, and this is vertical motion, so acceleration is going to be -10. Acceleration here is equal to -10 meters per second squared. But I can prove this one, and I say if we use F is equal to ma, we have there should be a force, maybe the tension, taking this one here, but the tension is not there, so we should say 0 minus. Now the weight of B, is 0.1 then times G, then is equal to we have the mass 0.1 times A. So do you see that the 0.1 is going to cancel with this one here, and then you get your acceleration, which is equivalent to -G. This is the one you get as what? The -10. Now, after that, then we look at this maximum height here, where it has reached. Okay? At maximum height, V is equal to what? 0. Now, I can use V squared is equal to U squared plus 2AS. Now, I'm finding this distance Y. So we shall have V is 0. Okay? And then the initial speed, the speed it starts with here. That is the one we got here. That's why I said same for B. Okay? Now, we are going to have root of 10 of x. And this one we square it. then plus 2 times negative 10, and then the distance is y. So this one will be negative 20y. When it crosses, it becomes a plus. So I'll have 20y, which is equivalent to, this square will cancel the square root, and then we get 10x. So meaning y can be equivalent to 10x divided by 20, that will be a half of x. So that is a half of x here. Okay. Now, remember they gave us here the maximum height. Okay. The maximum height, they gave it to us here as the greatest height of B above the ground is 1.2. So meaning I'm going to get this distance here, the distances here, I add them. There is this x here, there is this x here, and then there is y. Then they equate to 1.2. So we shall have x plus y is equal to 1.2. This is 2x here, then plus y, which is x over 2, which is equal to 1.2. And this is 2.5. 2.5 of x. Because if you have 2 plus the 0.5, then this one is equivalent to 1.2. That means our x is going to be 1.2 divided by 2.5. So therefore, what is the value of x here? 1.2 divided by 2.5. That is 12 over 25, which is the same as 0.48 meters. So that is that.